Hello guys. Today we are going to do this interesting question, text justification. The description is too long. I don't want to read them all. Let's just jump into the example here. So the input is this is an example of text justification. The max width is 16. So this means we are going to remodify the word so that it fill out the maximum ones. Okay, here's an example. From 1 to 16. Let's fill in the words and characters one by one. Okay, first word is this. Okay, so let's fill in this word, this. And also, the problem says we have to give at least one space in between. So 5 is a space, then the next word is, and then give another space. So starting from position 9, here we get an example. So an and another space, and then we try to fit in the example. Oh, okay, we reached the end of the wait, so let's jump to line 2. Example. And then give another space. Then next word is off. Give another space, and next word is tex. And then the last we try to add another space, and we reach the end. So the next word justification should be in the next line like this. Justification. Also, the problem says in the last line of the text, it should only be less justified. So here it is so it will our word will start with J. Okay, so we have filled out the words in every line. Now the problem is how do we move the spaces around such that it looks evenly distributed. Okay, here for example, we see there are extra spaces at the end of this line. So we are going to reorganize this line. How do we do that? Okay, from observation we can we notice at least we need to push the last word into the end. Okay, actually let's calculate how many spaces do we have. So from this S to this I, the space is 1, and from this S to the A we have a 1, and then from the N to the N now we have 6. We have 6 spaces. So this line we have 8 spaces in total. So now the question is how do we reorganize the 8 spaces such that the three words looks organized. So our goal is to put 8 spaces in between. 3 words such that the spaces are evenly distributed. So we know, okay, 3 words. 3 words. That means we have 2 slots. 2 slots means this is 1 slot. This is another slot. We have 2 slots to distribute the 8 spaces, right? And so each slot gets 4 spaces individually. So then the problem is really easy. So starting from first, let's think about the final result. First, the first word is always added in this line, and then now we are going to get 4 spaces. So from 4 and add 4 spaces, and then we reach to 9. And then after we so 4 space get the first word, and then add 4 spaces, and we add our second word is. After we get the second word, we add another 4 spaces. So from 11 to 14, these are 4 spaces. Then we add our final words. In this case, we get AN. Okay, so this is, let's think. Now, so in this problem, we fit, you can see, fit 8 spaces into 2 slots. So each slot gets 4 spaces. This is no problem. But what about, say, in another case, we have 9 spaces and we want to fit it into 2 slots. Then what do we do? So you want to say, so we have so one slot gets 5 spaces and another slot gets 4 spaces. So, and also let's go back to the question. It says, if the number of the spaces in the line are not evenly distributed between words. So here we have a 4, we have a 5. What do we do? Okay, the empty slots on the left would be assigned more spaces than the slots on the right. Okay, so then the left slot will get 5 spaces, and the right slot will get 4 spaces. Okay, and then now think about another situations. For example, we have 14 and 14 spaces in total, and then we want it to fit into 5 lots. So if we here, let's do a simple math here. So if we can distribute it evenly, then it will be 10, and so then we get a mod. We get a mod. This is 4. So we have 5. So we have 14 spaces we want to fit into 5 lots. So we have the number 2, 2, 2, 2, 2. We have 5 twos, but we have but there are 4 left. So what do we do about the 4th slot? So okay, let's go back to the question. extra spaces between the words should be distributed as evenly as possible. So what do we do about this extra? What do we do about this extra 4 spaces? We can add them to the slot 1. Okay, if we add this to slot 1, then slot 1 will have all these extra 4 spaces. Then slot 1 would have 6, and slot 2 has 2 spaces, and 2 and 2 and 2. You see, the summation of this is 14. But is this the result we want? Let's go back to the description. As evenly as possible. What does this mean? This means if we have extra 4, then we will only add 1 to slot 1. And then slot 2 has 3, and slot 3 has 3 spaces, and slot 4 has 4 has 3 spaces, and then the last slot has only 2. So we can see this is evenly distributed. So that example shows what does this say. Extra spaces between the words should be evenly distributed as evenly as possible. This is as evenly as possible. Okay, so I think after we read through the question description and I give a solid example here, the code should be very self-explanatory. Okay, let's go back to the code. Okay, so I'm using Java. The final result should be a list. So I have the result variable to store the result, the final result. Okay, first we do some null check. If the words is null or the words do not have any words in it, then we simply return the empty list. And then next we want to, I have a variable line which will store the empty list. So this is to, for example, in this case, the line would be the THISISAN, and I skipped the space here because I only want to know the valid words. And the length is the valid length of each line, excluding the space. Okay, then let's do the fun part. The input is a list of words. So for each word, in some cases, we directly add this word into our line. For example, THIS, this is the first word, is added in the line 1, and this is also added on line 1, and AM is always added on line 1. So what is the condition to simply adding the line? Okay, it is the result of the previous line plus okay, what is this? This is the space. So for when the line size is 0, we add the first word in this line. After we get that the line is 0, the line size is 1, which means we will need extra space to keep the line going. So this length plus size line means this, and then plus the length of the current word. So here, and then now we have the line has 2 words, so this line size is 2, which means this line need at least 2 spaces and the previous valid words and plus the current words. So if this is smaller or equal than the max length, then we keep adding. So then else means we try to add the example to line 1, but we find out the line is too long, it does not hold true, then we start to think of reorganize the line. So now we are going to reorganize the line. And since string is what is that? Inconvertible? Cannot be changed. What is that word? Okay, I forgot. So we use a string builder to build our final result of this line. So here we have, I created a string builder, and at some point, the string builder will be added to the result. The string builder is the final line, which is this justified line. Okay, after we get this line, we have to continue the search, and then we update the line to an empty array. This is and then we also add the current word. In this case, this example, we add the current word into the line, and then we update the valid lines for each line. So this step is really to prepare the next line. So at the word example, after we get an example, we have to do two things. The first thing is to reorganize the previous line, and the result is stored in string builder. At some point, do a lot of things, and then the string builder will be added to the final result. And the second thing is, since we get the example, we know this is the first word of the next line, and we need to do these things to prepare for the next line. Okay, then the difficult part is, how do we modify, how do we justify this line? Okay, so we have to think of, now we have to go back to the description. So in this example, this line has 3 words, so we justify the spaces in between. What if this line only has 1 word? What do we do? Let's see. Okay, okay, here's an example here. See, it says the second line is also left justified because it only contains 1 word. Okay, that means if this line only has 1 word, then we simply copy this word and fill the rest of the line with spaces. And if this line has more than 1 word, then we will reorganize the spaces in between. Okay, so for the simplest case, okay, so here we have a string builder. We are going to do some tricks on this string builder. Okay, let's see. Remember, the line we already let's first we want to check okay, no matter what cases, we have to know after we add these valid words, how many spaces are left in this line. So this is what it does. We have variable space at the end equals maxi length minus length. So this is to say, if I push or this line has 16 slots in total, characters in total, and these 4 are occupied, these 2 are occupied, these 2 are occupied. So I have 16 minus 1 plus 1 plus 6. I have 8 spaces to fill in the slots. So this is spaces at the end. Spaces at the end. And then the next is space in between. So this means I have 3 words, then I have 2 slots. Or yeah, it's probably better to say number of slots. Okay, then let's see. If this line only has 1 word, like we said before, we only do left justify. So then we simply append this word and then fill the rest with the space. So this is the rest. Okay, and then else, if we have more than 1 word, then we have to reorganize this. So how do we? So we want to transform this line to this line. Okay. Fully left right justify. So from the example, I think I already explained. So this variable space each in between means I have 8 slots. I have 8 slots. I have 8 spaces. I want to fill it into 2 slots. So in the ideal world, each slot would get 4 spaces. This is what it means. And the extra space means in the imperfect world. For example, I have 14 spaces and I want to fit into 5 slots. And each slot should get at least 2. So this 2 is space in between. But I have something extra. I have the extra 4s. And now I'm going to evenly distribute the 4s. So in the code, we first append the first word into at the beginning of this line, and then since we already know each slot should get at least, for example here, 2 slots. So now I prepare the spaces. So this after this for loop, I know each slot should contain at least 2 slots. 2 spaces. Okay, and then since we already get the first word, and then we will get for the rest of the word in this line. First, I will append the spaces, and then depending on if we have something extra, for example, here we have 4 extra, then I want to add 1, 1, 1, 1, and 0. And or in this case, in the previous case, 8 spaces fill into 2 slots. So each space get 4 spaces. That means we have 0 extra. Then we do not append at all. And then finally, we append the space, append some extra space if necessary, and then finally append the word. So that is basically 80% of the work, almost done. So here, like I said, result is the final list I want to return, but the result is only added in this else branch. So which means we do not take care of the last line. What do we do about the last line? Let's see. What do we do? For the last line of text, it should be left justified and no extra space is inserted between. Okay, so for the last line, we still use the string builder, and then finally we want to add the string builder to the final result. And since I already know we only have for the last line, we are going to left justify. So left justify means I will append the first word no matter what, and then for the rest of the words I simply append space and then append the word. And if there are still spaces left, then I fill the rest of the string with the empty with the space. Yeah, so it was that. That's all.